What is the relation between Kp and Kc? This is the question from chemical equilibrium. Equilibrium chapter दोस्तों is not difficult chapter. Please keep in mind it is very easy chapter. Like this relation. Sure, one question should be there from this relation. So first we derive this relation, then we do some numericals related to the same. So if question is, what is the relation between Kp and Kc? So you start with, consider a reaction. This reaction. In this reaction, how do we read it? Small a moles of reactant capital A reacts with small b moles of reactant capital B to give small c moles of product C and small d moles of product D. This A, B, C and D, these are stoichiometric coefficients of reactants and products. Now to write Kc, what is Kc first? Kc is equilibrium constant in terms of concentration, and you know concentration is written like this. So to get Kc, concentration of product of the concentration of products raised to the power their stoichiometric coefficients divided by product of the concentration of reactants raised to power their stoichiometric coefficients. This square bracket C, this is molar concentration of product C. Same is the case with D, molar concentration of product D. What is A? This is molar concentration of reactant A. And what is B? You can say now. What is B? This is molar concentration of, yes, molar concentration of reactant B. Good. In this way, now Kp. What is Kp? Kp is, like Kc is equilibrium constant in terms of concentration. Kp, equilibrium constant in terms of pressure. So again, this is pressure of C raised to power C, pressure of D raised to power D, pressure of A raised to power A, pressure of B raised to power B. Done? What is PA, PB, PC and PD? These are partial pressures of reactants A and B and products C and D. PA, PB. These are partial pressures of reactant A and B respectively. And same is the case with PC and PD. PC and PD, partial pressures of products C and D respectively. Now you know, according to ideal gas equation. What is ideal gas equation? You have studied in states of matter, even in first chapter. You know, PV equal to nRT. So now what is P? P is equal to N by V RT. And what is N by V? Number of moles per unit volume. And this number of moles per unit volume is known as molarity. So in this way, P is equal to molar concentration into RT. So likewise, what is PA? Concentration of A RT. What is PB? Concentration of B RT. What is PC? Bolo bhai. PC is, yes, concentration of C RT. What is PD? PD, concentration of D RT. So in this way, we get PA, PB, PC, PD. Now we replace PA, PB, PC and PD by these concentration terms. So Kp is equal to, PC is replaced by PC RT raised to power C, D RT raised to power D divided by A RT raised to power A and B RT raised to power B. So in this way, just separate concentration terms. These are concentration terms: C raised to power C, D raised to power D, A raised to power A, B raised to power B. What is left? RT, RT raised to power C, RT raised to power D. If base are same, then powers are added, and if they are divided, then it is subtracted. So RT in numerator, RT raised to power C plus D, and here RT raised to power A plus B. So tell me, what is this? This whole thing is, bolo, this whole thing is Kc. So Kc, now RT raised to power, yes, RT raised to power C plus D minus A plus B. What is C plus D now? Tell me, what is C plus D? C plus D is number of moles of product. And what is A plus B? Number of moles of reactant. In this way, what is delta Ng? This number of moles of product minus number of moles of reactant is called delta Ng, that is C plus D minus A plus B. That means this C plus D minus A plus B is replaced by delta Ng. And what is delta Ng? Change in gaseous moles of reactant and product. So in this way, we get Kp equal to Kc RT raised to power delta Ng. So this is your final relation. If question is there, what is the relation between Kp and Kc, then you end up your expression, your derivation up to this point. And to explore further, you can go like, if delta Ng is 0, then what is the relation between Kp and Kc? Delta Ng is 0, so that implies Kp is equal to Kc. If delta Ng is greater than 0, then what is Kp? Is it greater than Kc or less than Kc? greater than Kc, because something is multiplied by Kc to get Kp. If delta Ng is less than 0, then Kp is less than Kc, right? So, if question is H2 gas plus I2 gas to give 2HI gas, what is the relation between Kp and Kc? So, to get a relation between Kp and Kc, just calculate delta Ng. So, can you tell me what is delta Ng in this reaction? Yes, calculate. So, delta Ng is number of moles of product minus number of moles of reactant. So, product, there are 2 gaseous moles. In reactant, 1 plus 1, again 2. So, it is 0. That implies Kp is equal to Kc for this reaction. Okay, if we have reaction like this, calcium carbonate solid to give calcium oxide solid, CO2 gas. Yes, what is delta Ng for this reaction? Delta Ng, yes, bolo. It is 1 minus 0, that is 1. That implies Kp is greater than Kc. Because on product side, gaseous moles is only 1. That is CO2 gas. This is solid. On reactant side, calcium carbonate is solid. That means it is not counted, because we count only gaseous moles. Then C solid plus O2 gas to give 2 CO gas. Yes, what is delta Ng? Again, delta Ng is 2 minus 1. Product side 2 gaseous moles, reactant side 1. So 1. That means again Kp is greater than Kc. Can you give any example in which Kp is less than Kc? Think about it. So this can be like this reaction, N2 gas plus 3H2 gas to 2NH3 gas. Yes, what is delta Ng for this reaction? Product side 2 gaseous moles, reactant side 3 plus 1, that is 4. That means minus 2. So Kp is less than Kc. That's all for this relation between Kp and Kc. Thank you very much for watching this video. Do like, share